Greetings to all of you who wish to take my course. This course, the name of this course is Molecular Absorption Spectrophotometry for Pollution Monitoring. I want to give you a small introduction regarding the course, but before that I would like to introduce myself to all of you. My name is J. R. Mudakavi, and I am a retired faculty from Indian Institute of Science Chemical Engineering Department. I had completed my BSc from Karnataka University, MSc from IIT Mumbai, DIIT and PhD from IIT Madras. Subsequently, I had done postdoctoral research in Perkin-Elmer Corporation, where I specialized in atomic and molecular spectroscopy. And I have worked in Chemical Engineering Department of Indian Institute of Science for the last 36 years, and it has been my pleasure to be associated with pollution control, which is my passionate subject. Now, regarding this course, I would like to tell you that the pollution in our day-to-day life has been a reality. Almost every person living on this earth has been touched by the impact of pollution at some stage or the other. So, we are all concerned with the pollution of water, air and solid wastes. Now, this is a topic which interests me because the parameters which cause pollution are all related to chemicals and bacterial microbiological parameters, and my concern with respect to spectrophotometer, this course, is that the course provides you a very simple analytical tool to monitor the pollution levels around your environment. Sophisticated analytical methods are available all over the world, manufactured by multinational companies, but they are all very costly and not accessible to common man. But a spectrophotometer is found in almost every college nowadays, and maybe in government laboratories or at personal level, private level, etc., even at taluka level places. And spectrophotometric measurements are made about 30 million times per day on various aspects of chemical determination. So, spectrophotometry is a very common chemical technique nowadays, on par with gravimetry and volumetry, which are the normal procedures for wet chemical laboratories. So, the beauty of spectrophotometry is it takes you to the level of the determination in microgram and sub-microgram levels, which are the limits prescribed even now by central and state governments and international bodies also. So, majority of the parameters what I am going to describe in this course can be monitored by spectrophotometry. So, this course is designed to give you an insight into the instrumentation of molecular spectroscopy as well as the inputs to make you capable of determining the pollutants or at your own level using normally available chemicals across the shelf, and also during the process you are not going to waste any chemicals. That is one of the parameters which I have set myself in this course. Sometimes what happens is, quite often you will come across situations where a chemical after its use cannot be thrown into the environment again. So, we have to be careful as environment monitoring procedures do not themselves spill over into environmental pollution causing chemicals. Now, this course content gives you an insight into the atomic structure, that is electrons, protons, etc., how electrons are arranged in an element, and regarding the periodic table, and then I have planning to give you theoretical basis of spectrophotometry. What happens at the atomic level when spectrophotometric procedures take place. So, the detailed instrumentation of spectrophotometry also will follow after the discussion on various types of transitions that give rise to molecular spectroscopy. So, the molecular spectroscopy is the basis of pollution monitoring, and the whole process is carried out through a spectrophotometer which is available across the shelf all over the world, and you can buy it in using a very small for using, you do not need much money to buy the equipment. Now, I also want to teach you about the theoretical aspects and practical aspects of practice of spectrophotometry. What is Beer-Lambert's law, whether it is linear or not, and how we can estimate 2 or 3 chemicals simultaneously using a spectrophotometry, that is simultaneous spectrophotometric determination. Whether we can do some titrations also using spectrophotometry. It is a powerful tool. It is good to know the potential of spectrophotometry at any time. Now, I would also like to give you the parameters. There are about 30 to 32 parameters for water pollution monitoring, and I want to show you that at least 25 parameters can be determined by spectrophotometry. Others require different techniques, but we will not go into details. Now, why spectrophotometry again? There are technical reasons I wish to elaborate with you. Normally, I assume that you have the basic wherewithal, technical knowledge up to graduation in chemistry or at least intermediate. Now, if you take a look at the spectrophotometric methods, you will see that a standard spectrophotometric method requires you to prepare about 50 ml of the solution, minimum 50 to 100 ml, but for measurement you need only 5 ml. So, why you should prepare 50 ml at all or 25 ml for that matter. So, what I have tried to do in this course is to tone down the use of chemicals to the minimum, so that the final volume is retained only around 10 ml. So, the what we waste after the experiment is only 10 ml, and that itself is a good contribution. Then secondly, the spectrophotometric procedures what you come across nowadays in textbooks, they are all very old, especially the interference data is very old. Nowadays all our water bodies in rivers and bore well, etc., they are all contaminated to much higher level by a variety of organic and inorganic substances. For example, no book ever tells you the interference of surfactants, even though surfactants have become very common in our day to day life. We use surfactants, detergents, ionic surfactants, cationic surfactants, non-ionic surfactants, etc. They are all in our water bodies now. We use ethylene diamine tetraestic acid, that is a complex, that also is there in the water. So, we are also using several drugs. Every human being uses medicines, and these medicines are excreted from our body, undergo transformations, and during and end up in the river waters. So, there are a myriad chemicals, organic chemicals, which may react with the parameters, metals, etc., and those effects have not been evaluated in any textbook. So, we want to generate data for the myriad pollutants that are present in water, which were not there about 20 years before. So, this is also sort of a research experience for you when you go through this course, and also I am going to give you the technical know-how, how to monitor a particular pollutant and how to prepare the reagents, how to run an experiment, how to interpret the data. All these things I will be introducing to you in the latter part of the course. So, the course basically consists of the theoretical part and instrumentation part and applications part, and at the end of this, if you collect all the information, it will give you a sort of a cookbook which tells you that which prepares you rather to face any situation in a very confident manner, and also you will be compatible with the green chemistry with with these techniques, and I would like to congratulate you for choosing this course, and I hope the taking this course will be a fruitful experience to you, and I hope you will be benefited by one all of you will be benefited by taking this course. Thank you.